Hello everybody, in my last video I talked about how symmetries leads to conservation laws, and in this video I will talk about how symmetries leads to fundamental forces and what do we mean by symmetry breaking, which leads to mass of particle while leaving certain particles massless such as photon, gluon. So let's get into it. In general, there are two types of symmetries. One is called global symmetry and another is called local symmetry or local gauge symmetry. The global symmetry means where each point of a system transforms by an equal amount. For instance, if I push an object and this object contains a lot of particles and each particles is transformed by an equal amount. Therefore, it is called global transformation or global symmetry. And more examples from global symmetries are rotational symmetries, time translation symmetries, and they all fall under the category of spacetime symmetry, which I had explained in my last video. Whereas in local symmetry, each point transforms by different amount. That is, the transformations occurred locally instead of a global shift. To understand this, look at this clip. Here you hit the carom coins with a striker and these coins or carom men scattered by different amount. So this is an example of local transformation, but not local symmetry because the system was not invariant after the transformation. However, the local symmetry or the local gauge symmetry is more of an abstract symmetry where the transformations such as rotations occurs locally by leaving the system invariant or without changing the laws of physics. To understand this, let's dive back into the quantum chromodynamics, which I had explained in one of my previous videos. On that video, we have seen that quarks exhibit three colors or color charts: red, green, blue, such as an up green quark can transform into a blue quark and a blue quark can transform into a green quark. And during this transformation, green quark will emit a gluon such as green and anti-blue color gluon, and this color gluon will be received by blue quark, and by receiving this it will transform into a green quark. So try to see what happens. We started with green quark and end up with green quark, so the system remains invariant or the color charts remains unchanged, and this symmetry is represented by SU3 gauge group, here the gluon acting as a gas field. Similarly, the weak nuclear force or the weak interaction is described by SU2 gauge group, and electromagnetic force is described by U1 gauge group. Thus, this three symmetry gauge group explains the fundamental forces.